Hello. Let's get right down to it. You can tell by the light on the table. Hello, hello. Right on the fringe there, that's the best. Listen to that, can you hear that? I don't know if you can hear it or not. So that's a spherical rotor, that's awesome. Right on the edge there, that's awesome. Just doing this with a bifilar, you can't even tell that it's spinning, but it's spinning really fast. So cool. Hi. Awesome. Hey, Atlantic City, what's up? That's cool, man. That's really cool. All right. There is one thing that I wanted to really. All right. So it's about, typical pulse motor stuff and how this is so not that. All right. We're going to have 4 pickup coils this size go on first to each peg. And then we're going to have a drive coil on the outside, bifilar. And then we're going to tape it all down. We're going to make it solid. and then we're going to have a stator. Right, it's going to start out being one permanent magnet. And then I'm going to flick this thing, and the momentum is going to start it up. But every time one of these drive coils pulses, it's going to pulse into the pickup coil. And then I haven't really decided exactly how I'm going to utilize that, but I'm pretty sure a capacitor is going to be involved. It's going to be sweet. I'm going to get some ferrofluid going here too with the signal generator. I want to show you guys some frequencies. Somebody suggested that I use sand, and I will. I have some sand outside in the shed. I'm going to use some sand. Just have to set up a surface to do that on. Alright, so let me empty this out because it's all dried up. Okay, so we want to do that. We're going to want to turn off the power first, and then I'm going to hook up the signal generator. And then I'm going to take the camera off the tripod. Alright, so I'm going to fill this up and hook up the signal generator. Sweet. Just got a little drop on my finger, that's alright. Now the signal generator, we're going to clip it to the base. And the emitter. Okay, let me turn this on. Well, so we're going to start at 1. We're going to start at 1. So let me get that set up. Alright, turn the power on. And get the camera so you guys can see what's going on. Hello, hello. It's kind of a midday stream, I guess. Where I am, it's midday. Look at that. That is so sweet. Boom. Boom. Is there a way to like put a flash on? I don't see. Maybe the camera. I don't want to mess with it right now. Now let's try some megahertz or some. Let's start off with kilohertz. 1 kilohertz. See, 1 and 3 sounded the same. 10,000 hertz, 10 kilohertz. Look at our light. It's flashing. It's bright. This is ferrofluid. This is the magnetic field through ferrofluid at 10 kilohertz. I wish I could turn the flash on. That would be great. Okay. Haram in a good way or a bad way? Is it a curse or is it a treasure? It's definitely cool. That much I can say. You see that vortex, that pool in the middle? That is so cool. Now there's two. Now there's four. Wow. Three. Let's keep moving it up. Let's do 100 kilohertz. Yes, ferrofluid. Megahertz. That's a megahertz right there. Wow, man, I wish I could like get some light on that. Let's see, what does this do? Nope, that's not it. It's magnetic fluid that responds to magnetic energy. Not magnetic fields, though, apparently. It's not the field, really. You gotta get it really close to feel that. It's the vibration from the magnetic energy. Because I can make the spherical rotor, spin its fastest, like way out here. Like way out here, it'll spin faster than it will in the middle. But here, you can only get a response from the middle. And that's interesting in my mind. That's really cool. I'm gonna go up to 2 megahertz in just a second. .5. Holy smoke. All right. It doesn't look like we're getting any more like different responses, but you get those bubbles in the middle, and then you get all the strands going inward towards those bubbles, or maybe they're going outward from the bubbles. It's hard to tell. But if you're thinking vortex, they're going in. If you're thinking something that's expelling, they're going out. And then all that stuff go away as soon as you turn the signal generator off. So yeah, but I'm gonna bust out the sphere again. Now I do have the trigger coil hooked up, so I don't need the signal generator. But here, I'm gonna show you this. I need both my hands though. Maybe I can Bring this over here and bring it down some. There. All right. Let's see if we can get this going here. You can hear it, I hope. Yeah, it's going pretty fast. You know, like around the edge here, it's really strong, but it's like fringe, you know, it's like the ferrofluid won't respond to this out here. You need magnetic on magnetic, and that's like magnetic on iron, so that's not going to work. This works great though on field, you know, field on field, awesome. But like I said, you put it in the middle, it gets bogged down, it gets bogged down. Field on field, best way to do that. Woo! And then you move it this far away, and the light turns off. You know, this is pretty far for a functional coil. I mean, damn, that's far away. Like the light is what I'm judging by what the range is. There, it went off right there. That's pretty far. That's so cool. I mean, yeah. Oh yeah. Woo! The ferrofluid is definitely responding to this. It's awesome. Wow, dude. It's like responding to the electromag, but then it's also responding to the sphere itself. I wish I could show you this and do it at the same time. I wish there was a way. Oh, that's so cool. Maybe from the ceiling, but I don't have anything to hang it up there with. Let's see if we pull this in closer. Oh, son of a. Oh, no. Shoot. I gotta go wash my hands. It splattered out into the ball, and then it went all over everything. Like, what? This stuff gets really sticky after it. Yeah, I gotta put that ball in some soapy water. Woo! Yeah, that stuff spreads quickly when it's spinning that fast. Alright, so yeah, that kind of sucked. The ferrofluid like got too close to the sphere and got latched onto the sphere, and then it started to spin. I'm glad I got it all on my hands pretty much, because that stuff is nasty. Hello, hello, hello. Hello. How we doing today? 75 volts in. Less than 10 milliamps being drawn. That's so cool, man. No amps needed. No amps here. We might be generating amps, but we're not using any. Yeah, well, earlier I was using a Neo-Sphere for a rotor. That's what I was doing earlier. And I was testing out the frequencies with the ferrofluid just so we could see the magnetic field. But this is an electric motor with a transmission. So I got all these coils hooked up in series, right? And then they're all individually hooked up to the switch. Well, it's 2 coils per switch. And the switches are right here. I'm going to drop it to 50 volts and I'm going to throw the switch. Maybe drop it to 60 volts. Now watch. What increases is the output. The light over here is a lot brighter. We're still not drawing any amps. Now let me throw overdrive on. See that? But we're drawing like a whole amp and a half when we do that. That overdrive with the blue plasma, that costs a lot. Alright, I'm going to see about getting some of this ferrofluid off of the Hello. Yeah, we're just cleaning up here from a... Oh, it's coming off nice and good. It's easy. It's easy. I thought it was going to be hard, but it's not. Just that bowl that I was using is perfect for this. It's already all smoothed out from being used so much, and you know, it's just going to be sucked if I can't get the ferrofluid off the bowl. Coming off the ball pretty easy. So cool, so clean. Hey, Bale. That's what it's, or it's Bale. Hey, Bale. I love that. Hey, Society, how's it going? Yanni, what's up? Man, the ferrofluid just flung itself all over my magnetic ball. So, look at that. Man, that thing spins so good. So good. It spins so fast on a bifilar coil. It's amazing. And you get pretty good readings off the coil too from using it. It's like awesome. How's it going? Hey. So yeah, I got you guys up on the television. Alright, so this strangely enough, is my new design for a rotor that's going to use coils instead of perm mags. Each one of these pegs is going to get 2 coils, one pickup coil, which is going to be, 5 ounces of 30 gauge, and it's going to go on there like that, and then the 20 gauge and 28 or 26 gauge, I'm not sure what I want to use for a trigger, are going to go here, or it might be 30 gauge, 20 and 30. But, and then the permanent mag is going to be on the stator. And that's how it's going to work. I'm going to have a battery for each spoke, 9 volts. Or I could go with the 12 volt batteries, but I think a 9 volt's going to do just fine. I mean, let's test that out. We're going to put a 9 volts in. This is not going to be a good test, but it'll kind of give you an idea how fast it'll go. Maybe not. See, it's really hard for me to judge because it's a totally different design. Because see, the rotor will go in here like this and the coils will be on the rotor. So I don't know, man. I think the switch is a little tight right now. Oh wow, the switches work even at 9 volts, man. That's awesome. Let's throw overdrive in at 9 and see what happens. Oh yeah, man, I can hear that pickup speed. Wow. So what the difference is that when I throw, in the beginning, all these coils are hooked up. Then I started throwing switches. When I throw the first switch, these 2 coils are removed. The path of least resistance cuts these 2 coils out of the equation. And then the second switch cuts these 2 out. So it's like just these 2. Oh my God, it was so responsive at low voltage. But just winding those coils right now seems like a tedious job right now. I'll get around to it. But, yeah, all right. Oh, we're caught. We'll get that out of the way. All right, so 9 volts in, and all the switches are off, so all the coils are engaged. I'm going to throw this switch. These 2 coils, this one and this one, are now cut off. So you got the same amount of power going through 2 less coils, which means you're going to get a more vibrant response immediately from having less copper in the equation. It's a electric transmission, kinda, clutch, kinda. And then when you throw this final switch or overdrive, it removes these 2 coils, and then it's just this one and this one, and you're pumping all that, whatever amount of energy it is, just through those 2, it's going to start picking up speed really fast. See, like, this is just 9 volts in though. So I'll turn this off. So now it's got to go through all that copper, which is going to slow it down at 9 volts. I'm going to turn it up to 20 volts, 25 volts. So you get a little bit of speed, a little bit more speed with 25 volts, but it's still going to be slow compared to the other 2. So we'll say that's up to speed. We're going to throw this switch, and that's going to increase the speed, increase the output. My bad. All right, so that's gear number 1 at 25. Now let's throw overdrive at 25 and see what happens. There we go. So much better, like faster. And even at, because at 25 volts, you're still drawing 0 amps. See, no amps being drawn, or less than 10. Less than 10 milliamps. And the only thing that makes that possible is it needing to pass through 2 switches. You need to pass through this switch, and it combines all the energies. Then you need to pass through the trigger strand, which is on this one. So when the trigger's active, this switch has got to hit sometime in that time period for it to work right. All right, we'll shut these down. We're going to jack it up a little bit more. And just to show you, I'm going to show you that the amps are all the way to the right. Amp button is all the way up. All the way up. 50 volts. It's path of least resistance. All right, so I'm going to throw this on at 50 volts. Yeah, you can hear that. That's picking up. All right, let's see if we can get some amps off of this one. We can throw overdrive at 50. Look at that plasma. It's just eking, trying to get out of there. But yeah, we were drawing up to an amp right there. So you put a little bit of pressure on the switch and it'll start arcing. You take a little bit of pressure off and the amps go disappear, they just disappear. Is it cheating? No, hell no, it's not cheating. I don't understand what that even means, man. I built this from the ground up. I'm allowed to do whatever I want with it. Yeah, that's right, man. That's absolutely it. Cool. The only thing stinking over here is the ferrofluid. Definitely not smelling too red hot. All right, so where are we at? Yeah, the switch is hot. It's starting to stick. You can see it like when it sticks. Aye. It does have a, when it's light like that, when it's lit up like that, it does have more energy than when it's not. But it is also drawing more energy from the power supply when it lights up like that. You're actually pulling amps with the. But that's it, you know. That's that switch. That definitely you can draw amps there. And this one is the like the long drive one. This is going for the gusto at full speed type deal right here. Let her buck. All right, let's see what we're drawing on the cap bank. 75 volts in the cap bank, and we're running the light off the cap bank as well. Wow, man, I don't know. I just never saw it as being cool as I do now. You know, I always thought it was neat and everything, but now when I see it through other people's eyes, I'm like, wow, okay, maybe I was doing a little bit more than I thought I was, but maybe you shouldn't be too over gratifying. You know, I don't know how much like. See, to me, it's easy to do. To me, everything that I just explained to you about the transmission makes sense to me. So when you turn the switch on, you're actually cutting coils out. And that just makes sense to me. Um, you know, there was like a guitar player learned how to play guitar backwards and upside down. So, I mean, maybe I did. Oh, I am for sure. Can't take that away from me. Yeah, I was thinking about putting a hellback array in the rotor here. So you line everything up with this coil right here, and then you make left go that, or north go that way, and south go that way. Each magnet. So, you know, boom, boom, boom. And then you got a strong, you got a strong field that way. So if north is going that way, when you spin it this way, north is going to have a strong presence. When you spin it the other way, it's going to react differently. Yeah, I like experimenting with that Hellback array, or at least my understanding of the Hellback array. I just, you know, you got to point all your magnets going the same way, but you point them going left to right instead of either up and down or in to out. So, and it's good to have them all facing the same way. You know, I've actually wanted to do like one out, one up, one in, one down, one right, one left. You know, like just make the north face a different way 6 times in a row. Um, do you speak English, buddy? I have no idea what you're talking about, man. You need to learn how to like communicate a little better because I don't know what you mean. I really don't. Weight distribution, this is extremely well distributed. Yeah, honestly, it started out with me trying to please everybody, but I can't do that. So I've gotten the down, I got the tip on a lot of things, like how to make a, rotor into a flywheel basically, and have all the things utilized, flywheel utilization. You pack all the weight on the outside, you hollow out the internal part basically. And all this like floaty crap, I want to see it first. Seriously, man, I need to see that crap to even think about believing it. Now, I heard there was a way that you can turn the shaft into your electromags. You can turn your shaft into an electromag and it'll spin the rotor without any of this copper. I'd like to know how to do that. Now that somebody's told me that can be done, I'd like to see that done. I'm sorry, buddy. I know. I'm so sorry, man. I'll probably fix that later. But, I mean, what? I never said it would go forever. Man, you guys need to be here a little bit longer before you start judging me. That is awesome. Yes, this will stop, but yes, this is awesome. That's just from me pushing it with my finger. The bearings in here are hybrid steel and ceramic bearings with one of the balls purposely removed to increase speed, momentum, or gravitational momentum. So when you hook these up in a vertical setting, having that extra ball be gone really helps out with the speed and the momentum of the bearing. Just is. So cool, man. I looked in there. I'm like, man, one of the balls popped out. One of the ball bearings popped out, and I'm like, well, maybe it. And then the other one was like it too, and I'm like, nah, this is the way it's supposed to be. Hello, hello. See, so that's quite a ways that'll spin before it actually stops. Like unbelievable. And it'll start on its own. If it's got any kind of momentum swinging the switch, it'll start on its own. $75. No, I'm not using a battery. Because I'm not going for like an over unity thing or anything like that. I'm just having some fun. Hello, hello. Yanni, you the man. Yeah, the hand crank under the table. The guy, he's hooked up to the bicycle or something. And he doesn't get paid, you know, he does it all for free. He's like, I'm gonna get him this time. So let me kind of try to explain my new design here. Each one of these pegs is going to have one of these 30 gauge coils put on first. And then there's enough room for me to put another one of these coils. It's going to be 20 gauge and 30 gauge. And it's going to go on top. Then I'm going to strap it all in. I'm going to put the batteries right here. And I'm going to put the circuit on top of the batteries. Each MPN on top of the batteries. It's going to be parallel circuit. That's going to be awesome. I mean, if it works the way I want it to work, it is going to be so cool because it's just exactly the opposite of what a pulse motor is typically right now. See, all the coils are on the outside and the magnets are spinning in the middle. I'm going to do the exact opposite of that. About 640 RPMs. Bet I can get it going faster than that at 50 just by throwing the first switch. Maybe 60. $7.49, yeah, that's going up rather quickly. Oh no, okay, $6.56, $6.57. So it's a little bit more already. You know, you could let it run, but I'm just gonna. If this first switch is on, I'm gonna turn it up back to where it was. Still no amps being drawn. That's amazing. 684. Probably get around 700. I want to say is going to be right around where we're at with that. And when the two switches are active, you end up with a lower RPM, but way more energy than you would without them. Like way more. Like don't do it with not this way, more energy. If you want to get energy, do it this way. Because I'm going to show you what happens when I take the switch out completely. I'm going to bypass the switch right now. You'll be able to turn it up like a quarter of the way that you were before. And nowhere near as much power coming out. Just is what it is, man. Just is what it is. WYSIWYG, bro. What you see is what you get. All right, so we're already drawing 23 and 2.7, 270 milliamps. Let's stop it. Alright, it looks like we may have fried this transistor. I'll save it, but I'm going to switch it. Alright, let's see what we got. Wow. Usually the switch by itself goes a lot, or the trigger strand goes a lot faster. Hmm. It's something that doesn't seem right with the transistor. It just doesn't seem right. I think it's because that leg is bent. You know, if it was all clipped directly to the transistor, it wouldn't matter, but there it goes. Yeah, that switch is real finicky. So these are both probably good transistors. Hell yeah. Haha. Well, I'll tell you what I will do. I'm going to make a rotor that has the coils on it instead of the electromags. I'm going to do that. Um, I'm gonna make, yeah, that's basically what the challenge is right now, is to make an effective rotor that will spin at very high RPMs with all the power and everything it's going to need self-contained. That's what we were doing. Um, it's going to be awesome. And then we're going to do the magnet rotor, electromag rotor with the perm mag stator. So the permanent mags are going to be on the outside in the stator, and that rotor that I just showed you is going to spin. Now I can either put one, two, or four permanent magnets to make that work properly. That's pretty crisp light, electricity coming out for the light. Oh yeah, I'm not, what? Hey gnome, stop being such a troll. So what if it's been done? Nobody's done it the way I've done it. I'm not even trying to do it because it hasn't been done. I'm trying to do it because I haven't done it. Which has also already been done. So, you know what hasn't not been done? Nothing. Everything's already been done. I didn't. I said you need to stop being such a troll. Didn't say you were a troll. Why are you telling? I mean, what's the point of saying that it's already been done? Answer me that, and I'll leave you alone. You're trying to help. How? What? Why? How? How? I don't understand. Please help me understand. You've done nothing to solve the problem at all. Just made, allude that there was a problem. You got to follow through now. Yeah, I guess you're right. I'll figure it out on my own, kind of thing, and that's cool too. I've done a lot of different ones like this, actually. Um, it's just not typical, if you get what I'm saying. It's like the other way is the way people do it most often, because it is a whole lot easier. I'm not going to be using a commutator. I'm not going to be using any connectivity. It's all going to be on the rotor. So I don't know if this has actually been done before or not. Yeah, I'm not going to be able to get that off. So what's actually going to happen here, and I don't know. I mean, that'd be great if somebody's done this already. But like the pulse from the drive coil is going to electrify the pickup coil, which is then in turn going to electrify the caps, which is then in turn Probably not going to be doing too much except light up lights, unless I'm running the whole system off a capacitor. Then maybe it could charge itself, at least for 98%. And if it's running on pure voltage, then I could definitely do it. But I haven't gotten a second system to run on nothing but voltage. That's like, it doesn't work. Oh, it is floating. This is definitely floating. Yeah, I'm using the entire setup here to light up this cap bank. It's not BEMF though, it's just straight up flyback. Or from beginning to end. I think I gotta go, guys. DC. Using a lot of DC, and I'm converting AC into DC. So I'm using DC power, yeah. Hey, hold on just a second. The output is the light being turned on plus 75 volts. Hey, all right. So me get the bobbin size out of here. 3D printing. The bobbins are going to be about that full up with whatever I want to put in them. I was going to print out all the bobbins and then I found these, and these fit perfectly. I mean, they need to be strapped in, but they're like without hindrance, fit right on the knob there. So this is maglev, bouncing on a magnet. And it's dead center, so there's no like friction from it being off kilter or anything. I thought it did a pretty good job with that. So I'm pretty sure that this area right here, while I'm building this, is going to end up being for this rotor, just until I get it working. And then I might build a different one, a different base. So the ceramics, oh, there's bearings in there, but they're not resting on something like this one is. This one's not maglev, and it's just resting on that. On this is resting on it, so you got a lot of friction with this. And I'll show you why you don't have friction with the other one in a second. But that's going to be awesome when I hook up the rest of those coils. Whenever I get around to it. Slide right off the pole. That's awesome. Alright, so that's that. And now I'm going to show you. You got the black toroid on the base here. It's a dead center of the pole. You got your hybrid bearings on the toroid. See, there's even a magnetic pole there. Maglev in effect. So it reduces the friction of resting on the coupler. And you could argue that because of the bearings themselves, you don't get any friction when you do that. But you do. You really do. It's better off if it's not resting on anything. Yeah, I want to see you make that. No, I want to see that. I will subscribe to your channel if you make that. You hear me? I will subscribe to your channel with the rotating device with no shaft. So, I mean, the max I'm getting is like 1600 RPMs, man. What's the big deal? And I'm serious, man. Since you can't describe how to build what you're talking about, I can't wrap my mind around what you're saying. So it's like it's frustrating me. Like how to build it. I can't see how you can build that with what I have here. I'm not a philanthropist, dude. I don't have a bunch of money to throw around. So... Oh, that's cool. And you can do that. That's fine. I'm just going to ask you to explain yourself as politely as I can. You know what I'm saying? I want to know how to do all this stuff. You know, and that's how I learn, by talking to you guys. Yeah, no, dude, I'm not an engineer. I don't have any education in engineering. I throw this together on a whim because I knew how. What you're talking about, I have no idea how to build that. It sounds intriguing, though. Absolutely, man, to have this thing floating there in midair. And not a plasma toroid, you know, like something that'll actually, you know, create electricity. Not just look pretty. And I got two rules right now. One, I gotta be able to make it with the stuff that I have available. That's one. And two, I gotta be able to wrap my mind around it at least enough to get an idea of what it's supposed to look like. And that's pretty much it, man. If I can do it, I'll do it. And if I need help, I will ask for it. I love your ideas, but they are just suggestions. Like, The ones that I do are suggestions as well. And if you got money to back it up, man, you move up in the line. If you got money to back up what you want to build, you move up. You know, you move upward in the line of priority. So, I mean, it's only to minimize my own emotional entanglement involved in what goes on, you know? See, I don't want to be like, oh, man, I couldn't do it because I didn't have the money. I draw boundaries, you know, just for my own personal health. I think that's a good thing. Woo! Yeah. Don't want to be doing that at 75 volts. Woo! Okay. Yeah. I'm just happy there aren't any amps being drawn. 300 milliamps max. I like that. No, I don't know how to weld or solder. That's why all these clips are here. I'm getting a lot of sparks. I'll turn it down, like 37. Yeah, final product. I wonder. Oh yeah, this one has definitely got my intuition flowing. It's like when I use the signal generator to burst one of my coils, one of these big gray ones, and I have one of my pickup coils on top of it at like high frequency, you get a lot of energy off of them, like a lot, you know. So I was thinking pickup coil, and then on top of that, you get a drive coil, and when that drive coil hits, it's going to pulse the pickup coil every time, you know. And if we get a capacitor and maybe a dump, I don't know exactly how it's going to work here. I need maybe some help. But I'll draw a picture of it. But like all the batteries, all of its power is going to be on the rotor itself. And then its circuitry is also going to be on the rotor itself. So you don't need to attach any wires anywhere for any purpose. No commutator, nothing to worry about. So it's not analog, but it is hopefully going to be effective. Yeah. All right. So turn the power on. Move this coil over just a little bit. Move it up. Good. Just can move up a little bit. I can move in a little. Just nudge that baby. That's epic, man. That is a true. I can even put a coil here that'll pick up. Like a 7th coil that I'll use just for pickup. And I'll be able to light this light bulb with it and do other stuff with it. Let me crank it. Oh, the light's on. Yeah, light's on. We got switch 1 on. I've never had it this high with switch 1 on. 720 RPMs. That's with 8 magnets on the rotor. I guarantee you if I take 4 magnets out of this, I can get it up to like 1200. But I'd have to rearrange the coils. That's a huge project. Yeah, that's true. That's true, Yanni. The flyback can be higher than that, actually. 750 volts is your kind of your sweet spot for that. I've had it going up at least that high before. Well, at least my peak to peak was like 950 to 1200 RPM, or 1200 peak to peak voltage. So that's 1,200 volts. Hey, what's up? That's my bolt. I'm cleaning something off. Nice. Got that for being good? Nice. Haha. Move out. Yeah, you need to get the fuck out of there, man. Awesome, thank you. Alright, see you later. You gonna give that to me again? Oh, cool, thank you. Mm. You're awesome too. You guys all make this kind of worthwhile. So, yeah, you know. And I'd like to try more exotic things, but I gotta have what it takes, literally. And I got a whole shed full of stuff, though. You know, this isn't all I have, but it's all outside in storage.
How much?
Let's see here. 200 and 180 still.
180? That's a lot.
Yeah, considering there's no power going through it right now, this is all coasting. All coastability. And I think all the diodes I have hooked up in here are helping this thing perpetuate itself. But it's not going to go forever. It's just going to go a little bit longer than it normally would.
Okay, do you still have the thing on?
No.
Not that?
No.
So you just spin it?
Yeah. Well, kind of, yeah.
How long have you been making this?
I'm on like 3 years now.
3 years on this? Just
No, on all of it.
all of it.
I started doing this like 3 years ago. This one I made last night.
I couldn't take that one.
No. It's pretty good. It's pretty good.
I mean, just last night, that's a lot. Mail.
Bill's pretty good. You know, I don't keep lights on when I'm not using them. So, I mean, regardless of whether the bill's pretty good.
I'm not that I can make his own electricity. All that stuff. I mean, you got a lot of clips still.
Yeah, these are little clips though.
Ooh.
They tend to fry a lot easier than the big ones. That's why I'm using all the big ones. Because I want the connections to be good, to be crisp. And those little ones, they like fry. They break. Tiggs.
Remember a couple weeks ago, he jumped onto the wire over there. That was actually kind of funny. And he ran out because he jumped like
Overdrive.
on the ground to like right here.
So it's cool, and you have to hook it up this way for it to work this way, but the path of least resistance is what changes the transmission on this motor.
So I'm if you switch on and release.
Well, they're both on. You want to turn them off?
That's right.
Okay, the other one? Nice. So I'm gonna start. We'll start it from the start here.
Last time?
Oh yeah.
This way?
Other way. Right on.
So it just goes faster?
Yep, it's gonna go faster, and then we're gonna let it get till it stops going faster, and then I want you to flip the first switch. Yeah.
I'm trying to make sure which one you're talking about, because from your perspective, it's like, this is first for you. So you're talking about first for me.
All right, I'll let you know.
What's this?
That's my new design.
Oh.
So simple, right?
Really cool.
Yeah. True that, but this one's got a transmission.
This is coil design?
Yeah.
Alright.
Yeah, that's the bobbin size. Actually, I'm going to use a little bit bigger one. That one, yeah. All right, throw it first. Hold on, let me get this.
Hold.
236. 238. Go ahead, switch it. So we got 238.7.
I want to be in the live stream as much as I can, so I'm just doing the best I can.
So the torque is definitely increased. The rate of speed is increased. So we're at 323 RPMs, 26. We'll give it another 30 seconds. 335.
Do I turn the other switch on?
Not yet.
Not yet. So this is what you did before I came in? I had a feeling it was going to be a yes. Because this is that fast.
All right. Throw the switch.
So it's going to get even faster?
Yeah. It's going to get faster at a faster rate.
So faster out of faster. It's like faster.
Yep, it's going to get faster, faster. 420.
420.
Mhm. This is 19 volts in.
19. 19.7, so almost 20.
Yeah, if you could get the name of that for me, that would be awesome, because that'd be useful. Really useful. else fails, I'll ask chat. 460. I do like to give people the opportunity to answer the questions, though.
We're almost in an hour. And quarter, 2/4 in the back.
What's wrong with you, Teddy?
It's a motor.
Thank you. Alright, I'm going to have you switch those again. I'm going to stop it.
So we're doing it again?
Yeah, you can start it. Hold on, let me get the right amount of juice in here.
So like...
Alright, go for it.
It's like 15?
No, spin the wheel first. It's alright, you're good. 45 volts in.
45? I thought that thing can only go up to 25.
It's a different thing.
Different?
Mm-hmm.
So it can go up higher?
Mm-hmm.
I've never seen 40 before.
350, 360, 370. This is no switches at 45. That's all the copper is in play right now. $3.90.
So do I flip it?
Yeah, you can flip it. Wow, you can even hear that acceleration rate increase.
So it gets faster every single switch?
Yeah. That's why we start over again, so you can actually tell.
Okay, now Tiggs is taking a minute.
Tiggs? No. No bugs.
And it's not far enough, I believe.
Yeah, you don't want to. Okay, 487. Throw the other switch. The light went on.
So the switches?
Leave that one. That's fine. I'm gonna get a reading here. 500. 505.
The lamp light turns on.
Yeah. Too bad you, well, you can kind of see it.
But it's like you can see out the window.
Open a portal to the White House. Hold on a second. No, what's a waste of time and money? Now you're getting personal, jackass. Alright, well, I think we're going to be wrapping it up then pretty soon, since the mood's kind of changed a little bit.
I think that was a big yawn.
Good, good Tiggs. Don't get shocked, little pigs.
If we get shocked, we're probably gonna jump. And we're probably run as fast as we can out the window.
I'm having fun for the most part. Sure, I'm gonna have to put that in my list of words that I will not allow on my channel. One is waste. I will not allow that word on my channel. You think about saying wasteful tidbits, you'll be banned automatically.
Oh no, it's moving.
Well, I'm gonna put them in the ignore bucket.
Let's get to about 2 hours and then we can.
You wanna keep going, son?
Yeah,
You can do that.
I want to keep going until like we hit 2 hours.
Okay. Okay, what can we do? Do you wanna use the Ferrofluid?
Yeah.
My hands are still black from that. All right, let's hook it up. Could you hold that? You might be able to even get, the upward visual from this.
I'm gonna put it on the ground.
Mm-hmm.
And now he's taking a nap over here. Let's hit about 145.
Uh-oh. Can you get me that rag over there, buddy?
This one?
Mm-hmm.
I can tell that you've been using this.
Mm-hmm. All right, Wonder, do you want to take that out of there, or do you want to just so you can show people?
Yeah.
All right, here, let me do it. All right, so let's take a look at the black stuff, Ferrofluid. Look at it with the camera, Caleb. All right. Mm-hmm. Can you get this shot? Like hold it like that? Yeah, that's the energy going through.
Do I hold it?
No, this camera. Get the shot that I'm getting. Don't hold it like that. Hold it so you don't drop it.
Like face here?
Mm-hmm.
Can you hold it? I'll be right back.
Mm-hmm.
Alright, I will be here next live.
Mm-hmm.
So let's put it back in here. Bye.
See ya. I'll hold on to it.
Alright.
Man, I want to spin my ball. But I know that bowl is covered in ferrofluid right now. Probably can print another one. A better one. Oh, I got an idea. That's going to be a more exact fit. Yeah, I got to print another bowl, I bet. It's a perfect fit, though. It's a U-tron, half of a U-tron, designed to hold this ball, actually. Huh. Well, kind of out of ideas here for right now. So the ball is not going to happen right now. That's okay. I love that ball, though. That spherical, man, it can spin like a champ. I mean, it sounds like a razor saw. That's overdrive from the get-go. At 42 volts in. So right now, just this coil and this coil are working. Yeah, electromotive force. And then the EM field, the electromagnetic field, creates electricity through being pulsed through copper. That's what that does. And then the electromotive force is what actually pushes things. It's two different types of force, often mistaken for the same thing, I think. I do it a lot myself. Can't wait till I can get enough money to get the Anno game that came out just this past day. Dude, I love Anno. I'm gonna jam out, man. I'm gonna fucking have a great time. Whee! I do have a terrible habit of got a potty mouth. It's my fault. I work on it hard though, all the time. No, Robert. Robert. Uh, English, please. Hello. Hello, hello. I, A, E, I, O. Ooh. Y. Yeah, I'm sorry you're so blind. Been doing this for 3 years, not even an accident. Oi. I've had some accidents with magnets and such. But you're not my father. See ya. All right. But I am planning on getting that other rotor done, the 4 coil rotor, and that I think is going to be like my main focus for right now. I got some awesome stator magnets that'll work for it once I get it set up. It's going to be great. I would say it is a more efficient motor. Um, with the paperclip switch and the trigger coil both in action, there are no amps being drawn. When I say no amps, I mean below 10 milliamps. Below 10 milliamps. So I'll take that as a no for the English, Robert. And it's also got a transmission. Thank you, thank you, thank you. We're going to be wrapping up things here in a little bit. I really appreciate everybody hanging out. That's the power being used right there. 75 volts, 0 amps. Well, there might be some on the other side of that 0, but that's less than 10 milliamps. RJ, so I'm just explaining, this is a little bit different than your typical motor. Your typical motor requires amps to run. It just does. But when you switch it both ways, when you switch it with an analog switch and a trigger switch, and you amplify it through an MPN, you don't need to draw any amps. Sure, it's a... Well, I'll turn it down to 50 and show you how it works. Alright, we got no light reaction. We're at 50 volts in, 0 milliamps, or maybe 10 milliamps. We'll call it 10 milliamps. And then we're going to throw our switches. Okay, and what each switch does... Right now, all 6 coils are in play. So I'll throw switch number 1. And then this coil and this coil are now out of the game. I change the path of least resistance to the end of the green coil. So now it's just the green coil, the 2 gray coils, and the big coil over here. Now I'll throw the switch again. I'll throw the second switch. And that's going to remove the green coil and one of the big gray coils. And now it's just this coil and this coil. But our lights lit up. We haven't changed the power in any kind of way. And we're getting a little bit of plasma. So I'm going to see if I blew the transistor right there or not. No. Less than 49. Fuck you, Yuri. I don't like that word. And screw anybody who uses it. In my presence, anyway. Call me a jester? Man. Okay, all right. Yep, it's time for me to go. Have a great night, people. Please like, subscribe, and have a wonderful, wonderful night. Bye now.